This is for Lab 10, going over structures, as well as a little bit of linked lists. So Lab 10 is going to be exactly the same as Lab 9, except instead of dynamically reallocating your arrays with the realloc function, your arrays are going to be linked lists of constantly changing size. So first I want to go over structures. As structures, you can think of structures as a way to package data. So for example, to define a structure, I first say type def struct, and then my structure name, I'll just name it str1. And then right here, I would copy that name over. And then inside here, I can have any type that I want, or a series of types. So I could have int I could have or an array. I have to define a size though if I have that. So any type I want, and all these data types will be packaged under kind of this one type. So for example, a use case of this would be if I wanted to return multiple things. If I had a function, I can have it return the str1 as the return type. So this structure is now a new data type that you've made. And then I can say my return value, the data type of my return value is str1. I can say my return value dot I equals 1, dot j equals 2, and then I can return my return value. If I were to call this function, I'm going to make another one, returned, and then I can printf both I and j right here. So let's see that. I and j. Run that, we see I get 1 and 2. So I've, even though we can only return one thing from a function, I've packaged two integers as one thing. So this custom data type is representing these two integers. Another really useful use case of of structures is linked lists, which is what you'll be using this lab. So a linked list is, instead of every element, all the elements being in a row in memory, in a single block of memory, a linked list has every element is a standalone and has a pointer to the next element. That means the elements don't necessarily have to be next to each other in memory. That does mean they take up considerably more space in memory, so linked lists are not always the best to use. Also, they're slower to index. So if I want to get the fifth element from a linked list, if I only have a pointer to the first node, the first link, I need to go through the first, then to the second, then to the third, then to the fourth, and finally I can get to the fifth after jumping through the first 4 nodes. So they're less efficient to actually get a value from, unless you're getting them all at once. So as I mentioned before, a node, I'm going to redefine this as a node. I'll keep I as my value. Actually, I'll keep the integer as a value and rename it value. And then, as I said before, it's going to have a pointer to the next node. So that's going to be node next. Obviously, there are a lot of different types of linked lists. For example, if I wanted to, I could keep 50 values here instead of just 1, and that would cut down on the memory cost of these linked lists. Alternatively, I could have a prev node here, and this would keep track of the previous node, so I could go backwards and forwards. That's called a doubly linked list. I could have, there's a bunch of types of linked lists. I'm just going to go over a generic one directional. That's all you'll really need for the lab, and that should give you a good idea. So to start out with, I've got my structure. Next, I need to make the head node. So what I personally like to do is make the head equal to null. I set the head equal to null. And then I make a tail node, or a tail, and I set that to the address of head. The tail, I'm using the tail to know where the next node should go. So if I'm creating a new node, this is the tail will hold the address of where it should go. So right now, it's storing the address of head. So that means if I make a new node, I store it in tail, it's going to store it as head. So to make a new node, all this stuff should really be functionalized, but I'll just do it in the main function. To make a new node, I first need to allocate memory for it. So as you learned last lab, I can do size of node. I'm going to cast the return type as a node pointer, and I will say new node equals this. If I want to set the value of value in this new node, because it's a pointer, there's actually a shortcut I can do. Instead of dereferencing it and saying dot value equals 5, there's a syntax shortcut where you can do this little arrow, and that's the same thing. So I'll show those side by side. These are the same exact thing. Same exact thing. This is just a little cleaner and a little more clear. So I make the new node by allocating memory for it. I set the value of it to 5, and then this is really important. I make sure to set the next also equal to null. So now I've got my new node. I just have to decide where to put it. As I said before, tail is the pointer to where I should put it. So I can put it at star tail equals new node. Star tail is referencing head. So this is going to essentially be the same as head equals new node. But the advantage of this now is I can set tail equal to the memory address of my new node next. This. So now the next node, the next time I do these lines, it's going to put the node at this, at the next value. Okay, so let's just I'll make sure that compiles. Incompatible pointer type. So looks like new node next is a, oh, there we go. Unknown type node. That is on this line, presumably because I haven't defined it yet. So only after this semicolon, basically, after this is completed is node defined. So if I define it here, I actually have to say struct node, and that depends on what version of C you're actually compiling on. And there we go, so that fixed it. Okay, so now I'm gonna add one more node here. Just like this, I'm going to set the tail equal to new node. I'll move that step up. Okay, but this node I'm going to set as 6. So you can see how we're doing the exact same code here. This is very easy to put in a function, and you should put it in functions. So now how do I print this? I'll say linked lists lend themselves really well to recursion. So I can continue to print values while the node I'm looking at isn't null, or while the next node isn't null, or something along those lines. But for now, I'm just going to print them using just the pointer. So I can say head. I know head isn't null because I just set it right here. So I can say head value, and then for the next one, it would be head next value, and so on. Like if I had many more of these, I would do next. Obviously, that gets hideous, and you'd want to make a recursive function to iterate through these nexts. Or it wouldn't even have to be a recursive function. You can make it a while loop very easily too. Okay, redefinition of new node, of course. So I'll say new node 1, new node 2, and just replace these ones. There we go. Go ahead and run it, and we get 5 and 6. So these are the basics of linked lists. Again, I highly recommend putting these in functions. I recommend putting the printfs in functions for the lab. They don't have to be recursive necessarily, but at least make them not so you have to do next just to print a couple of the values. All right, that's it.